So it's 54 and 218. This is the information given we are asked to graph. It says, let me read. Sketch a graph that possesses the characteristics listed. Answer may vary because there is more than one correct answer, of course. Okay. So I'm going to start with, of course, this. So at -1, the function is -5. Done. At 3, the function is 2. Done. At 7, the function is 10. Done. F prime of -1 is 0. Done. F prime of 7 is 0. Done. F double prime of 3 is 0. Done. F double prime of -1 is positive. Done. And F double prime of 7 is negative. Done. Okay. So obviously, this is the situation. If that's the situation and this is a critical number, -1, -5 must be a local min. At 7, there is another critical number, and the function opens downward, so this must be a local max. At 3, 2, the second derivative is 0, and it changes sign, so this must be an inflection point. We identified everything. We're ready to graph. An example of the function. So definitely in the table, in the graph, I have to have -1, have to have 3, I have to have 4, 5, 6, 7. Then at -1 is -5. 1, 2, 3, 4, 5. At 3 is 2. At 7 is 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now we're ready. I think we are. Opening up at -1, -5, this has a local minimum. Okay. So then it will have an inflection point. Opening downward, opening upward, it has a minimum at -1, -5. It gets to a 3, 2, which is an inflection point, where it changes concavity. At 7 is 10, and it's a local max. It has to turn if it's a local max, and do whatever. This is how we are going to use this table to graph functions. Without organizing the information in the table or a table, I would have not been able to come up with a graph and analyzing what I'm given in the problem. Any questions about this? Any questions? I want to look at one more problem. It's a word problem. It's the coughing velocity on page 219. A person coughs when a foreign object is in the windpipe. The velocity of the cough depends on the size of the object. Suppose a person has a windpipe with a 20-millimeter radius. If a foreign object has a radius r in millimeters, then the velocity v in millimeters per second, of course, needed to remove the object by a cough is given by. k is some positive constant, 20r squared minus r cubed, where r is between 0 and 20. I'm going to change this into a different notation because I don't want you to get confused. This is the windpipe. This is the radius. Okay. K is a positive constant. For what size object is the maximum velocity required to remove the object? So, in other words, the problem is really asking us to find max velocity. And then I will know the size. Okay. So for the max velocity, I know I have to find v prime of r. K is a constant, so I'm differentiating k 40r minus 3r squared. I will set this equal to 0. I divide by the constant, it goes away. 40r minus 3r squared equals 0. I don't solve equations with a negative leading coefficient, but that's me. So 3r squared minus 40r equals 0. I will factor out r, and I get 3r minus 40 equals 0. R equals 0 is not a possibility because we're not talking about nothing in the windpipe. And R equals 40 divided by 3. And this is in millimeters. Now, we know that this should, because it's a quadratic function with a negative leading coefficient, this should give a maximum. But that's not sufficient. I have to show that R, I have to, at any point in time, millimeters gives max velocity. Very simple. R, v prime of r, 40 divided by 3, 0. Here's my velocity. I plug in 1. When I plug in 1, I have 40 minus 3, so this is positive. And when I plug in 100, this is negative. This is typical for a local max. How much is the local max? If you want to determine it, it's v of 40 over 3 is the max velocity. And we can determine it if you want. But we don't have k. But that will give us the maximum velocity. Any questions? I consider now 2.2 completely exhausted. Everything is done. So now we finally can put everything together and start graphing. We are ready to do so. But we were not ready when they told us we were ready. So we can go back and choose any function to graph. Now we are ready. We have all the information. And or we can move on to rational functions. Can anyone give us an idea? Would you like to now go back to graphing? And now we can put everything together.
Yeah, can we do that, the graphing?
Yes, let's do the graphing. Let's choose a polynomial function, degree 3 or 4. Let's look at problem 20 on 218, and then I'll stop. 20 on 218, which is f of x equals 2x squared minus x to the 4th. And this time we want to fill up the table with all the information needed and graph it. Not just fill up the table, but use the table to graph it. Okay, since this is a polynomial function, we know the domain is all real numbers. So there is no problem there. Good. I will first determine the limits. Limit as x approaches infinity from 2x squared minus x to the fourth, and limit as x approaches negative infinity from 2x squared minus x to the fourth. Can anyone give us these two limits? So this is too small. When I plug in infinity with minus in front will be negative infinity. And this is, when I plug in negative infinity, this is still infinity with minus in front, so it's still negative infinity. Good. Next I have to find the x and y intercepts. When I plug in 0, I get 0. But when I set y equal to 0, I have 4 solutions. So y equals 0 means 2x squared minus x to the fourth equals 0. Of course, I will multiply everything by negative 1, and I get x to the fourth minus 2x squared equals 0. I will factor out x squared, and I get x squared minus 2. So here are our 4 solutions. 2 of them are 0. One is the square root of 2, and the other one is negative the square root of 2. I'm going to put those in the table. If you have any questions or something is wrong or you don't understand something, I'm hoping that you will stop me, right? So the square root of 2, the negative square root of 2 here, and the square root of 2 is here. There is nothing else I can find about the function from the function itself. Now I'm ready to move on to the first derivative. So f prime of x is 4x minus x to the third, 4x minus 4x to the third. And when I set this equal to 0, I will have 4x cubed minus 4x equals 0, and I'll divide by 4. X cubed minus x equals 0, or x squared minus 1. And here are the 3 critical numbers. X equals 0, x equals 1, x equals negative 1. I have to squeeze them in the table. Okay. Negative 1 is here. 0 and 1. And now I have to study the sign of the first derivative. This is the first derivative. I'm going to plug in 10. Negative 10 here. Negative 10. So this will be negative 10, 1,000, negative 1,000. This is positive, and this is too small to mention. Now I have to squeeze something in here like negative 0.5. If you have any doubts, you can put the function in the graphing calculator, and which is 4x minus 4x to the third, and plug in some numbers. And I'm going to plug in negative 0.5. I'm going to plug in 0.5, and I'm going to plug in, there is no need, but let's say we plug in 10. Okay, with negative 0.5, which is here, is negative. With positive 0.5 is here, which is positive. I get 1.5. And with 10 is negative. Very crowded in here. Okay. Now I have to find the function value at 1 and negative 1. Let's see. With negative 1, where's my function? Where's my function? Oh, here's my function. Yes, right here. So with negative 1, I have 2 minus 1, which is 1. With 1, I have 2 minus 1, which is 1. It's an even function, so I expected that. Negative 1, 1 is a local max. 0, 0 is a local min. 1, 1 is a local max. And you can say not so fast, and I would have to agree with you. I have to study to make sure that these two rows go well together. So let's try. From negative infinity to 0, yes, indeed. From 0 to 1, yes, indeed. From 1 to 0, yes, correct. From 0 to 1, yes, correct. From 1 to 0, yes, correct. Yes, correct. Good. Nice. So finally, I have the second derivative to find. And I have 4 minus 12x squared. It's getting very crowded because now the second derivative is 0, means 4 minus 12x squared equals 0, or negative 12x squared equals negative 4, or x squared is 1/3. Ha ha ha. Nice. So x equals plus or minus the square root of 1/3. Where will I put that in? Have to put it in here, and my table will be messed up. I have to write it again because I want you to see what I'm trying to do, and there is not enough room in there. I should have made all my calculations first, but I wanted to show you step by step, so that's why I put them in step by step, and now I don't have room to squeeze in here and in here the negative the square root of 1/3 and the positive square root of 1/3. So I'll be more mindful about the space. Okay, so we have the zeros here, here, and here. The signs. Okay. We have for this, we have 0, negative infinity. For this is 1. For this I don't know yet. For 0 is 0. For this I don't know yet. For 1 is 1. And for the square root of 2 is 0. And this is negative infinity. Wow, nice, interesting. Okay, so now I have 0 here and I have 0 here. And I can study the sign of the second derivative very easily. At 0 is positive, and outside should be negative. So if I put in 10, this is going to be negative. If I put in negative 10, this is going to be negative. Okay, so it opens downward, opens upward, opens downward. This is a local max. This is a local min. This will be an IP. This will be an IP. And this will be a local max. But I'm missing these two. Not a big deal. Put the function in. 2x squared. Can I determine that without the calculator? I think I can. Let me see. So f of plus or minus is not going to make any difference. So plus or minus the square root of 1/3. This is 2 times 1/3 and minus 1 over 9. Yes, okay. So the least common denominator is 9. So 6 minus 1 is 5. Okay, so 5 over 9 and 5 over 9. What a messy situation, but we are going to be able to graph it. Since the numbers are so small, I'm going to say 1, 2, 3. 1, 2, 3. Okay. 1, 1. That's it. Okay, ready? I'm going to plot the points I have. Negative the square root of 2 is 0. Oh, that's not a good color. Okay, right here. Negative 1, 1. Negative the square root of 1/3, 5/9. 5/9 is a little bit more than half, so somewhere here. 0, 0. And then it's symmetric on the other side. Same thing. Okay. 0, 0. I have to have the same thing here. I have to have 1, 1 here. And I have to have this point here. Okay, ready? It's coming from negative infinity, crossing at this point, fine. Opening downward, increasing. It's increasing to the local max of negative 1, 1. Where I should have written this too, so we can see it. Okay, so it's decreasing now to this point, fine, which is a point of inflection where it changes concavity. It will start opening up and have a local minimum at 0. It goes up till the other point of inflection where it changes concavity, where it's going to a maximum, which is 1, 1. It will come down because it's now opening downward and decreasing all the way to negative infinity, crossing at positive the square root of 2, going to negative infinity. So this is our function. I think it was 2x squared, right? Minus x to the 4th. Before knowing all this, this would have not been possible without a calculator. But now you have the knowledge of the first and the second derivatives, and this is